A capacitor is an electronic component that stores electric charge. It consists of two conductive plates separated by a dielectric material, which can be air, paper, plastic, ceramic, or some other insulating material. When a voltage is applied to the plates of a capacitor, one plate becomes positively charged and the other becomes negatively charged. The amount of charge that a capacitor can store is determined by its capacitance, which is measured in farads, F. A capacitor with a higher capacitance can store more charge than one with a lower capacitance. Capacitors are used in many electronic circuits to store energy, filter out unwanted signals, and smooth out voltage fluctuations. They are also used in power supplies, timing circuits, and oscillators, among other applications. Some common types of capacitors include ceramic capacitors, electrolytic capacitors, film capacitors, and tantalum capacitors. The choice of capacitor type depends on the specific application and its performance requirements. There are various types of capacitors, each with their own characteristics and applications. Some of the most common types of capacitors include 1. Ceramic capacitors. These are the most commonly used capacitors and are made of ceramic material. 1. They are small, inexpensive, and have a low capacitance range. 1. They are used in various applications like RF filters, decoupling circuits, timing circuits, and voltage regulators. 2. Electrolytic capacitors. These capacitors have a very high capacitance range and are used in circuits that require large amounts of capacitance. 2. They are made of aluminum or tantalum and have a polarity, which means they need to be connected in the correct orientation in a circuit. 3. Film capacitors. These capacitors are made of metalized polyester, polycarbonate, or polypropylene films and have a low leakage current. 3. They are used in audio circuits, timing circuits, and power supplies. 4. Tantalum capacitors. These capacitors are similar to electrolytic capacitors but are made of tantalum. 4. They have a smaller size and higher reliability than electrolytic capacitors. 4. They are used in applications where high performance is required. 5. Supercapacitors. These are high capacitance capacitors that can store a large amount of energy. 5. They are used in applications like backup power systems, energy harvesting, and electric vehicles. 6. Variable capacitors. These are capacitors whose capacitance can be adjusted. 6. They are used in tuning circuits, oscillators, and filters. 7. Mica capacitors. These capacitors are made of mica and have a low capacitance range. 7. They are used in high-frequency applications, such as RF filters, and in circuits that require stability over a wide range of temperatures. 8. Glass capacitors. These are capacitors made of glass and have a high capacitance range. 8. They are used in applications where high stability is required, such as in resonant circuits. These are just some of the many types of capacitors available, each with its own unique characteristics and applications.